first lesson of our next unit is on polygon angle sum theorems. So first off, guys, a polygon is just an enclosed shape created by line segments. So don't let that throw you off. It's any enclosed shape. So it could be a triangle, a square. It could have any number of sides as long as the sides are created by line segments. So I could just give you guys the rule for our first theorem, but I want you guys to kind of discover it along with me because the theorem makes a lot more sense when you can analyze some of these polygons. So let's first look at this one. So I'm just going to make note this is 4 sides. And let's look at this shape and let's see how many triangles we can create based off of drawing lines from one vertex. So I'll show you guys what I mean. So from this vertex, I can create 2 separate triangles in this quadrilateral, right? So 2 triangles. If I were to ask you guys what's the sum of the angles within this shape, because it's made out of 2 triangles, right? And I know that these 3 angles will add to 180. These 3 angles will add to 180. To find the sum, all I have to do is 2 times 180, which would be 360. So this goes for any 4-sided polygon. Your total angle measures are going to be 360. Now let's look at this next one. We have 1, 2, 3, 4, 5, 6 sides. I'm going to start at any vertex. Start at this one. I'm going to see how many triangles I can create. So I have one right here, one right here, and then that breaking up into another 2. So I have 1, 2, 3, 4. If I were to figure out what's the total measure of my angles, my interior angles of my polygon, it would be 180 times 4, which is 720. All right. So notice we multiplied by 4 here, we multiplied by 2 over here. Next one, we have 1, 2, 3, 4, 5 sides. Take a vertex, divide it up into triangles. 1, 2, 3, 180 times 3 is 540. All right, so I multiplied by 3 here. All right, so 5-sided shape, multiplied by 3, 6 I multiplied by 4, 4 I multiplied by 2. Maybe you guys are recognizing a pattern here. The last one we'll check. 8 sides, start at a vertex. So here we have 1, 2, 3, 4, 5, 6 triangles. $180 times 6 is 1,080 degrees. All right, so with 8 sides, we multiply by 6. So you guys notice the pattern here, right? We basically are taking the number of sides, I'll say that's n, for number of sides. I'm subtracting 2 from whatever number of sides I have, and then I'm multiplying that by 180, right? So 8, I subtracted 2 to get 6, multiplied by 180. For 5, subtracted 2 to get 3, multiplied by 180. So you guys see the pattern here. That results, scroll all the way up, to our first theorem. All right, polygon angle sum theorem. If you know the number of sides of your polygon, you just subtract 2, multiply by 8, 180, and you get the total number of sides. So I'm going to have you guys pause the video and try actually all 3 of these. So problem 1 as well as these 2, you're going to use that equation n minus 2 times 180 to find your sum of your interior angles. here are your three answers. So for 1A, for a heptagon that's 7-sided, you just plug in 7. 7 minus 2 is 5. 5 times 180 is 900. And then for 1A, 17gon. So notice if you were to try to draw this out, that's going to be very tedious. So it's important we use the formula here. So 17 minus 2 is 15. 15 times 180 is 2,700 degrees. And then part B, the sum of the interior angle measures of a polygon is 1,980. How can you find the number of sides? So here you could just work backwards, plug in your degree measure. We're trying to find n. So working backwards, divide by 180 on both sides, you get 11. Then don't forget to add 2 to both sides. You get your number of sides is 13. You could always check that by plugging it back in for n, and it should give you 1,980 degrees. All right, here's some vocab to be familiar with, guys. So equilateral, equiangular, you guys have used those terms for triangles. So here we're just applying them to polygons. But you'll also see this term called a regular polygon. All that means is that the polygon is both equilateral and equiangular. Okay, all the sides and all the angles are congruent. All right, corollary to the polygon angle sum theorem. So this is the formula we can find each interior angle of a regular polygon. So if we have a polygon again that's both equilateral and equiangular, and we wanted to find what just one measure was of one angle, we can use this theorem, which makes a lot of sense, right? So this top part is just giving us the total degree measure, right, of the interior of our angles, which we just went over. And then when we divide by n, that's just dividing by the number of sides, or the number of, actually I'll say the number of angles. Here it's the same, the number of sides will be the same as the number of angles, but here we're trying to find the degree measure, so I'll just refer to it as the number of angles. All right, so applying it here, let's see. So we have a common housefly, I'm not going to try to pronounce that, has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. What is the measure of each interior angle of one hexagonal facet? So a hexagon, hopefully you guys know, is 6-sided. You can also see it here. 1, 2, 3, 4, 5, 6. We're trying to find the measure of just each interior angle. Okay. So I'm going to use that formula. N minus 2 times 180. So I'll find the total degree measure, and then I'll divide that by the number of angles I have. So I have 6 minus 2 times 180, and then I will divide that by 6. So 6 minus 2 is 4. 4 times 180 is 720. Divide that by 6. Each angle is 120 degrees. I mean, looking at this, if it looks more or less like a regular hexagon, that looks reasonable, right? It's greater than 90 degrees, but less than 180. All right, let's see this one. Okay, what is the measure of angle Y in the pentagon? So recognize here, this is clearly not a regular pentagon. You have different angle measures, so we're not going to be using this formula here, but we will want to use the first formula that I showed you guys about finding the sum of the interior angles. So let's first find the sum of the interior angles. All right, so I will use that first part. So n minus 2 times 180. So here I have 5. 5 minus 2 times 180 is 3 times 180, which is 540. All right, so that's the total. And we're trying to find the measure of angle Y. So we know every angle, I'll just write it in this box here, that's 90. So I want to add up 90, 110, 120, 150. See what that total is. Let's double check with my calculator. So that total is 470. So that's all the angles that we know so far. Let's just subtract 470 from 540. That's what should be remaining, which is 70 degrees. All right, and that looks reasonable, especially because when I look at each of these, the 150, 120, those all look like they're about to scale. Yep, and 70, that does look like it's less than 90. All right, guys, you try problem 3. Pause the video, try it, and then we'll go over it. Right, hopefully you found 102 degrees. I'll show you guys the process. You want to figure out your total angle measure. And you guys, as you practice these you won't necessarily need to use this every time. You might just come to you, but for a four-sided shape, your total is 360 degrees. You add up the angles you do know. You get 258, subtract that from 360, and you get 102 degrees, which looks about right, considering that each of these looks about to scale. Okay, a little algebra now before we move on to the next theorem. So here we're using the same process. Let's find the sum, and then we can figure out what y is. So let's find the sum. We have 1, 2, 3, 4, 5, 6 sides minus 2 times 180, 4 times 180, which is 720. So we know that's the total. And now we'll just set up our equation. Be careful here. I recorded this once, guys, and I realized this is being applied to this angle once as well as this angle. So just a little bit deceptive here. So let's just be careful that we set up our equation correctly. So I'm going to actually write, so I'll include these two y's. So y plus y. And then I actually have 2y minus 20 twice in each of these. So you know what, I'll just write it out. You guys could just multiply it by 2, but I'm going to write 2y minus 20 twice to account for this one. And then 2y minus 20 twice for this one. If you wanted to just use the distributive property and write 2 and then parentheses 2y minus 20, that's fine. I just want to make it super clear what I'm doing here. I know I'm running into the other problem, but I'll erase it later. So I have that long equation for this one problem. Let's add up our like terms. We have our 2y, so 2, actually I'll use a different color here. 2, 4, 6, 8, 10y. And then negative 20, 40, 60, 80. Lots of terms to combine. Right, but we know that the total is 720 degrees. Add 80 to both sides. We get 10y equals 800. Divide by 10. Y equals 80. All right, which looking back there, especially when you're looking at these two angles here, y being 80 looks reasonable, a little bit less than 90 degrees. All right, you guys pause the video and try that problem to the right. We'll go over it. All right, your answer here, guys, is 25. So really the place you want to double check is just combining all those like terms. I didn't write them all out because there are just so many. So, and you guys can do this too. Like I like to cross them out to make sure I'm not double counting or missing anything. So I just went through and I added up all of my x terms. I got 21x. Then I just broke up my others. So I thought of, okay, I saw the 15s to get 30, negative 10 is negative 20, and then I have the 5 there. Okay, so just make sure you're careful combining like terms there. When you combine the 30, negative 20, and 5, you get 15. Subtract 15 from both sides, and then divide by 21. You get x equals 25. All right, so that was talking about the interior angles of our polygon. We're now going to move on to the exterior angles, which looks a little bit strange drawing, extending your sides to create your exterior angles, but the theorem here is actually even easier to work with. So you can draw exterior angles at the vertex of a polygon. The figures below show the sum of the measures of the exterior angles. So here, when you're drawing the exterior angles, guys, you just want to make sure you're not like creating more than one at one vertex. So think of you're just extending each side, right? So if I'm going here right to left, I'm extending that side, and then I'm just continuing along my polygon to extend these sides. Okay. And the easy theorem that you guys need to remember about this is that the total of the sum of the exterior angles is always going to be 360. And it doesn't matter whether you have 3 sides, whether you have 5 sides, 20 sides, your exterior angles will always add to 360. Okay? And we'll play around with that. We'll work on looking at different examples so you guys can make sense of why that's the case, because it doesn't seem like it should be. So here's just another statement of that. Add up your measures of your angles, of your exterior angles. Remember, exterior. It'll always add to 360. Okay. So to find the measure of just one exterior angle, if you have a regular octagon, or really just any regular polygon, if it's regular, right, that means it's the same, all the same sides and same angles. So all you have to do is divide by the number of sides. So here with an octagon, we know the total is always going to be 360, right? Doesn't matter what number of sides we have. Just divide by the number of sides or number of angles. 8 right here, 360 divided by 8 is 45 degrees. When we look at this, I would say that looks reasonable, right? 45 is about half of 90. That looks like a reasonable answer. All right, you guys pause the video and try number 4. A nonagon, I will tell you guys, has 9 sides. Try it, and then we'll check it. All right, not much to this, guys. So we know it's always going to be 360, the sum of the exterior angles, right? So just divide it by 9 this time, you get 40 degrees. That's it.